Okay, welcome to this video. We're going to go through some more problem-solving questions I was asked to do. So these are from the first and second review sets and also some other questions from this chapter. So review set A, go to question 9. For what values of k does the graph not cut the x-axis? All right, so we've got a quadratic equation here. All right. And just remembering that you can actually use the discriminant to determine what values you won't cut the k-axis, and the x-axis rather. All right, so let's have a look at the discriminant for this one. So question 9. All right, if 2x squared plus 5x plus k equals 0, that's when you find the x-axis, hit the x-axis. All right, discriminant is equal to b squared 5 squared minus 4 times a times c. All right. All right, 25 divided by 8 seems to be the point at which that's where you would touch. Okay, but actually, I should have actually changed that. Okay, I'll change that actually because I actually want it to not. So it needs to be less. It needs to be negative. All right, so if that's less than, that's less than. Okay, if I subtract 25, I don't have to change the direction, and then divide by 8 is completely fine. All right, if k is less than 25 over 8, for those values you have no real roots, and therefore on the graph you not cut the x-axis. Okay, so also got question 10 in a similar kind of question. Find the values of m. So these are all discriminant questions. Has a repeated root, two distinct roots, no real root. All right, so the first one. All right, first of all, let's just go find what the discriminant is for this one. Okay, so we got the b value is minus 3, so square that, minus 4 times a times c, which is m. Okay, 9 minus 8m. Okay. All right. So just remembering the discriminant. So we are doing a repeated root is when discriminant equals 0. So 9 take 8m equals 0. Bring the 9 across. Actually, I'm more inclined to do this and then divide by m. M is equal to 9 divided by 8. Okay, as such. B, all right, two distinct real roots is when it's greater than 0. So 8 greater than 0. 9 is greater than 8m, and divide by that. Or essentially, if I switch the sides, I have to switch the direction. Just be careful with that. M is equal to 9 divided by 8. All right, just from kind of process of elimination, we can actually quickly do C. No real roots is the case where the discriminant is less than 0. And then you find, well, you got equality less than, then this must be greater than by definition. This is all the space that's left unless you made a mistake elsewhere. So that's how you find those. Okay, so that's 10. I'll go in 12. Show that no line with the y-intercept 10 will be tangential to the curve of the equation. All right. All right. Now, I'll explain to you what that means in the visual respect. When you had lines to a curve. no line with a y-intercept of 10 will ever be tangential to, all right, so let's consider this. All right, if I had a line, or maybe I'll just draw a quadratic. And I have a quadratic here, and yeah, it may be that one, it may not be. I'm just drawing this for example. Okay, so what does this mean? Well, you can have a line that might be that could be drawn as tangential. So that's kind of effect, and you could that's the only line I believe you can draw. Perhaps another one going up. I'm not sure. But I've drawn a line here that is tangential to this curve. That's what it means. Okay, so let's consider it another way. Okay, a line with y-intercept of 10. Okay, let's just come up with that as a statement. We can write a line as y equals mx plus c. So we'll say mx, and the c is the y-intercept. So we just make that 10. All right, so now our quadratic is y equals, okay, so we got that. Now, a tangent only touches once. So if the way to think about that, if I was to find the solution of these two, find the values of where they're equal, if I only get one solution, then that's a tangent. If I get a repeated solution, then it has cut through more than once. So there's another line that passes through 10, and see how that cuts through. If I get no solutions, like the line going down here, then, well, yeah, that's another step. How does this connect to our theory? Well, basically, if the line is tangent, then, okay, roots, so remember, roots just means solutions of an equation. Roots of mx plus 10 equals 3x squared, 7x minus 2, have one repeated solution. Okay, now again, let's connect that back to our discriminant theory. What I'm going to do is I'm going to write that with everything on one side. So I'm going to subtract mx and I'm going to subtract 10. So you can write it as. Okay, sorry, the camera's a little bit. Maybe I'll just raise it up a bit. Maybe I'll set some more background light here. It's not helping much. Oh, never mind. One repeated solution. So bring everything across. 3x squared plus 7 minus m, lots of x, so I move the m across. And then minus 2 minus 10 is negative 12. Okay, now I don't have to find the solutions for this. Well, I could find the solutions in terms of m, but let's just find the easy way to do that. Let's see if, let's find out what the discriminant is and show that it can't be 0. So the discriminant is b squared minus 4ac. We're going to see if we can make that equal to 0. Now I'm just going to double check I've done this right. Minus 4 times a times c, if I bring that across. Copy everything down correctly. There's no line with y-intercept of 10 will ever be tangential to the line of the tangent curve equation. Yes, that's great. All right so far. Okay, so can I make this equal to 0? Then you can find a tangent. Well, simplify this. All right, I'm just going to grab my calculator. All right, so stop doing stuff in my head. 3 times 12. Okay, 144. Yeah, actually, I see what the problem is. Okay, here's where you're going to be able to encounter an issue. If you bring this across the other side, well, you find here, okay, equals minus 4, 4. Now, you can't undo the square, at least not on the set of real numbers. So no solution in real numbers. Okay, so and I'll put out the fact that, okay, this is the final statement. As delta cannot equal 0, then there's no repeated roots, and that implies no tangents for lines of c equals 10. All right, so let's move on to the next question. So that was 12. What are we doing next? We're doing 13. All right. So question 13. Okay, so let's have a look at that. Write the equation that in the form of, okay, hence goes to the graph of the quadratic. All right, that's alrighty. Basically, the way we go about doing that is kind of like completing the square. Question 13. So write in that sort of form. Y equals 2x squared plus 4x minus 3. Okay, so if you do completing the square, let's start off by maybe doing this. Since we have to write in the form of a, so I'm going to take 2 out of the equation. 2x plus 3 on 2, or minus 3 on 2. Or should I do that at all? No, let's just take that out. Let's not do that. Let's just take it out of here. Okay. All right. So I just want to complete this. All right. Y equals 2x squared plus 2x. Now, if I add 1, that's fine. But I also have the minus 1. Okay. And keep that minus 3 out there. So I'm going to complete the square with this 3 terms. So that would become y equals 2x plus 1. Now I'm going to put a double bracket in here. Squared minus 1 minus 3. Okay, just expand. You can keep the 2 in front of here. Expand the 2 into there and just do that. 2x plus 1 squared minus 2 minus 3. So times by that, 3. Okay, and then finally you have it. Okay, the graphing part, well, you use the vertex, the idea that the coordinates of the vertex. Well, actually, I've got the y-intercept as well, just from that form. So Not sure if that's cheating, but yeah, if you substitute 0 into there, you end up with -3 anyway, so I already know the y-intercept. And I know the vertex is -1, -5. Okay, so that's the vertex. We're going to just draw this now. It is also concave up as well. So, all right. So I put this as -1, -5, and it kind of comes up like that, goes through -3, and has a symmetry on the other side. There you go. Something to that effect. Okay, moving on. Let's find some other questions to do. So we've done those ones. Let's do 2B. All right, 2B. Questions 5, 10, and 14. Move across. Consider quadratic that. Find the equation axis symmetry and coordinates of the vertex axis. Now, the easiest way to find the axis symmetry is the formula minus b on 2a, if it's expanded. All right, so let's use that. So we've got equals -8. For 3, okay. All right, so 4/3 seems to be the answer. I just wrote that down there, 4/3. All right, so all right, so I'm just going to put that in the calculator. Purpose of that, you can simplify it. So I'd have -16 on 3 plus 32 on 3 plus 7. Okay. If I've done that all right, times by 3. I got the answer for what the y coordinate of the vertex being 37 on 3. So the coordinates of the vertex thereby are 4 on 3, 37 on 3. Double check the working yourself if you like. I'm not going to go any further with that one because I've got other questions to go on with. All right, so let's have a look at. Okay, for what values do C do lines of the equations that intersect the parallel in 2 distinct points? Okay, well, basically similar to the one we did before. All right, so 10a x squared plus x minus 5 equals, okay, bring everything across to one side, x squared, that will be minus 2x, and I've got plus, and I'm just going to organize it like this. I have my reasons. Just makes pointing out the discriminator easier, equals 0. Okay, so basically the roots of this, to make that have two distinct points, the roots of this must be greater than 0. So b squared minus 4 times a times 24. Yep, so c, yeah, I've got c of minus 6. And essentially I can pick any point greater than that for part B. Okay, so part B, like any value greater than 6. So I'll pick if c equals 0. If c equals 0, then I can just go back to the equation. Choose one point in C, find the points in each section in this case. Well, then it says points in section. I think I did this question before, and I also picked c equals 0 because it's made things easier. Okay, equals 0. Solve that however you like. So I'll just, so minus b, plus or minus. Well, actually, I'll just substitute in. So it says 2 plus or minus 2 squared minus 4 times 1 times 5, 2. All right, square root 24. Oopsies, I don't need that. Sorry. 2 plus or minus root 24 on 2. Yeah, that looks about right. Okay. Now, can I reduce that down much? Not really. I can write 1 plus or minus. Okay. Can I take 4 out there? 24, yes. So you can actually write that as plus or minus root 6. Okay. Yeah, I think I have actually done this one before. And now if I substitute back into the linear equation, so remember it's kind of y equals now 3x because you let c equals 0, then equals 3 times this. Then that's the so now we've got the coordinates essentially. The coordinates are 1 plus root 6, comma 3 plus 3 root 6, 1 minus root 6, and 3 minus 3 root 6. There we go. All right. So moving on. Okay, that was question 10, 14. All right, 600 meters of fencing used to construct 6 rectangular pens as shown. Show the area of each pen. So each pen, okay, so each pen is just one of these rectangles, X by Y. All right. So we have to come up first, we come up with a relationship for the total perimeter. So if you count the number of X's here, 1, 2, 3, 4, 5, 6, 7, 8. So let's write that down. 8x. So we've got 8 of those plus. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9 y. 9 y's. Okay. We have a total of 600 meters to use there. So now I can write Okay, I can write y in terms of x. If I was to move that across, 9y equals 600 minus 8x. Divide by 9. Okay, area equals x times y. All right, so x times, and we've got the equation as asked for. Okay, n meters squared. All right, find the dimensions of each pen so that the maximum possible area. What is the area of the pen in each this case? Now, there's a couple of ways you can do that. One, you can actually go and find the vertex, or actually I should say from that, expand and find the vertex. You might find this a bit messy with the numbers, so I'm just going to do this with technology. Okay, so let's go pull up the graphics calculator again, and we're going to, all right, so we will now go and I'm going to go to the graph section, Y, and I'm going to delete that. I'll just press clear, never mind. And I'm going to go X bracket, okay, 600 minus 8x, close bracket, divided by 9. That'll be the same. Okay. All right. Now graph that, and you will see you will not see the graph. Okay. Well, we have to zoom to a suitable level. Okay. So zoom out. Zoom out more than that. No, it's going to take a while to do this. It's a positive, it's a negative quadratic. So I know the maximum's up here somewhere. So I'm just going to go, let's go into window. All right. So I need a lot more, the kind of the negative x space that makes sense. So I'm going to go with, I'm just taking a guesstimation of 30. Sometimes that's what you got to do. I don't, negative y space doesn't make sense. Remember the y represents area in this case, not the y that we got here. And okay, well, obviously we're well below what we need. So I'm going to say it's about, I'm going to go with maybe 200. Let's see what happens. You can put in some numbers in there, just try yourself and make some guesstimations. But okay, nope, need a lot more than that. Okay, let's go down to make that 2000. Nope, and we need more X space. Yeah, a little bit of try error doesn't hurt too much. But okay, so let's go with 60. And okay, we actually probably don't need as much as that, but we'll see what happens. There we go. That's a nice curve. Okay, now go into calc, and we're going to find the maximum. Okay, maximum left bound. Yep, a little bit left. And let's go to over to the other side, right bound. And we'll take a guess. And maximum is that. So maximum occurs at, so I would say by using technology. So in your answer, say using technology. I would say actually the kind of the point I was making in this sheet, I was saying, okay, or yeah, you could do it that way, it would take you longer. Using technology, maximum occurs at x equals 37.5 meters and area equals 1250 meters squared. All right, so there we go. That is that. All right, do we have to do anything more with that? Was the area? Oh yeah, I've done both parts. Find the dimensions. Well, I haven't quite answered the question in terms of dimensions because I haven't found out what y is. Well, y equals. Okay, let's get out of this section. Let's go back to our calculator. Oopsies, lost him. There you are. All right, back to this mode. All right, so 600 minus 8 times divided by 9. Oopsie, yeah, times by 9. Okay, then I better divide that by 9 twice. Okay, and that's it, isn't it? Okay, 600 minus 8x over 9. Yes, that's okay. So then y equals approximately 33.3 meters. And I think I've gotten more. That's all I needed. And I've already answered part B. So there you go. So there's the dimensions. Okay, so actually I do have some other questions. You have to go back to 2G for them though. All right, let's go back. Problem solving with quadratics. And looks like we're going to be doing some more of these. Righty. Well, that was actually optimization, that question. But problem solving, okay, 9 and 11. Okay, rectangle ABCD is divided into a square and a smaller rectangle XY. Okay, golden red rectangle. Oh, I see. Okay, so AB over AD. All right. Okay, the smaller rectangle BC, okay, BCXY is similar to the original rectangle. All right. So if you kind of view it this way, okay. If I was to say that, I'll draw this. Okay, so these values would be X. And I'll say that maybe, oh, and that is also X, and I'll make these Y. Okay, let's do Y. All right. So this rectangle with Y's and X's is similar to the larger rectangle here. So, okay, so in the larger rectangle is, okay, the long side is X plus Y. And these sides will be X. Okay, so in that respect, so I've actually, that rectangle, so you've got this rectangle, copy that over here, the smaller one, and this large rectangle, I've turned it around and just kind of put it on the scale on over here. So the rate, when you got something similar, you can work with the ratios. So if I did X plus Y divided by X equals Y divided by X. Okay, so that there's more to it than that. Let's have a look. All right, let's have a look at AB. AB, as I've called it, AB over AD is, okay, in my drawings, this is X plus Y over X. Okay, but because these are similar, then the similarity means I can divide things in ratio. So then Y divided by X is, well, actually, I'll do it the other way. I do X divided by Y equals Y divided x plus y divided by x. Looking for another equation to go into this. Let A L. Oh, I should have looked at the hint. Okay, I'm just going to reply. Let's just do it their way. All right, so we're just doing this. I mean, I've got that thing for any length, but if we just start with, I'm going to keep my A, or my A to B is x plus y. Um, ah, okay, let's just redo this. Sorry. All right, so I should have just done it by their hints instead of there. Okay, so we just start with the unit 1. 1, 1, 1, 1, 1, 1. Okay. And AB, okay, A to B is x. That's x. That's 1 as well. Okay. So this length here could be considered as x minus 1. So let's look at these similar triangles. Okay, the larger, sorry, I keep saying similar triangles, similar rectangles. The larger rectangle, this one just turned around, is 1, x, and the smaller rectangle is x minus 1 and 1. So the way to think about it is this. Okay. 1 divided by x, because they're similar, okay, equals x minus 1 divided by 1. If I times both sides by x, I'll have 1 equals x squared minus x. Bring that across. X squared minus x minus 1 equals 0. And, well, I just solve that using the quadratic equation because it's, well, actually, no, no, yeah, well, okay, so, all right. Quadratic equation, okay, minus b, 1 plus or minus 1 minus 1 squared, minus 4 times 1 times minus 1. All right, over 2 equals 1, okay, 1 squared plus 4 is well, root 5, 1 over root 5 on 2. Yes, as desired. Now just double check. Yes, well, plus or minus, and I think in terms of length, is it so the idea the ratio x must be greater than 0, thereby x equals 1 plus root 5 on 2. I think that makes sense. And just to check, well, that's x. And the ratio itself, AB over AD, well, that's, so if you do AB over AD, that's equal to x divided by 1, which is the ratio as proven. Okay, there you go. There's your proof. All right, that's question 9. Okay, and the last question we have to do is question 11. So another page by Celeste. Question 11 on the same page. All right, a stone is thrown into the air at the top of a 60-meter cliff above sea level. Stone reaches maximum height 80 meters above sea level. Okay. Reach maximum height. Okay. So we could have a relationship in terms of now. So you consider it this way: stone is you've got a cliff. Okay, cliff has got 60 meters. All right. So okay, 60 meters not too long. All right, stone is turned up. It reaches a height of 20 meters higher than that, which is okay. That's now at 80. Okay, and then I imagine. Okay, now I'm going to make an assumption. If it's assuming the quadratic model, then this occurs at 2 seconds, and then it's going to be at the same height 4 seconds later. All right, because of the kind of the idea of the maximum. So it's the maximum value of the quadratic, and thereby, okay, well, there's a symmetry there. And I've even kind of drawn it. I've drawn it like more like it's moving over the cliff as it's thrown, but this is actually a time scale. So think of it this way. Okay, if I was to draw up the axes, this axis is going to be time, and this one's going to be height. And it starts at 60, and then it's going to be at 80, and then it's going to be at 60 again in the same interval of time. Hopefully that makes sense, because at the maximum, you got the symmetry. All right. So, and it makes sense. It's not going to be a quadratic going up because it's not going to, the rock's not going to throw itself out into space. So if you're modeling with a quadratic, which you can do, is actually anyone who's actually done physics might remember this, b naught t plus half a t squared. Well, guess what? There's a quadratic model in terms of time. So it does work. And also a is a constant value. And okay, but yeah, we have initial v naught as well. So it's actually a quadratic. So let's see what happens. All right, so we've got 3 data points. The first one is, okay, at t equals 0 seconds, h equals 60. All right, we've got t equals 2 seconds, h equals 80. And we've got t equals 4 seconds, h equals, well, that'd be 60 again. So let's have a look. Hopefully that's enough to solve this. So if we just talk about a general quadratic, so we'd come up with height equals at squared plus half, sorry, what am I talking about? Blah, 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 b t plus c. Okay. When time equals 0, then c equals 60. All right. So we've actually solved one variable. When h equals 2, so I'm writing h as a function of t. H is 2. We have a2 or a2 squared, which is 4. b2 equals 80. All right, and we've got h4. Oh, sorry, I forgot the 60. Plus 60 equals a. That's important. Plus 60 equals 60. Okay, so then 16a, I'll just reduce these ones out. 16a plus 4b equals 0. And this one, 4a plus 2b equals 20 if I bring that across. All right, so let's take those out and just we'll just do a little bit of oops, actually, I might even just write this one out a different way. Divide this by, because you actually can divide both of these by 2. So I'll do that. 2a divided plus b equals 10. And this one, I can divide both of them by 4. 16, 4a plus b equals 0. All right. All right, so if I was to subtract I'll subtract the second equation, so first equation from the second. So 4a take 2a is 2a, and b take b is beta b is 0, and I think that would end up, so and end up with minus 10. That gives me an a of minus 5, which is what it is. This is not actually gravity, unfortunately. But it is a problem solving question, so it is. Okay. Actually, no, it makes sense because it's half a t squared. So that coefficient in the physics that actually is consistent. A lot of mathematicians work with the assumption that gravity is 10 meters per second squared. So that actually makes sense. Half a. So if that was 10, then half of a would actually make minus 5. But it's a, that's acceleration a, and this just happens to be the coefficient for t squared, which would actually be both. So that looks right to me, and then just substitute to find b. So uh, minus 5 plus b equals 10. All right, move that across, b equals 20. All right, so in that respect, we found the quadratic equation. Let's go write it out. Function of h as a function of t can be expressed as minus 5t squared plus 20t plus 60 meters. There we go. There's your function. Find the stone's height above sea level after 3 seconds. Okay, let's find it. 3 equals, there's calculator time. Minus 3 minus 5 times by 3 squared. Okay, plus 20 times 3 plus 60 is 75. So 75 meters. And that makes sense. So at 3 meters is kind of coming down, but hasn't come down to 60. So we're about here. All right. Was there anything else? How long would it take the stone to hit the water? All right. Well, let's find t equals 0. All right. So minus 5t plus 20t plus 60 equals 0. Now, actually, I'm going to times everything. Sorry, divide by, or you can times by negative fifth, but divide by 5 in each of the terms. Minus 5 t squared minus 4t minus 5 would actually make that. That'd be positive 12. Negative 12. Can I factorize that? Probably can. 12 and 1, 6 and 2 at the end, negative 6 and positive 2. Looks like it. Yep, equals 0. So actually the only answer that's useful, you actually do get two answers, minus 2, which we're going to discard, and 6 seconds. So why do we discard negative 2? Well, that occurred in the past. Now, in the past, if this was thrown up from the ground, up and over, but no, it was thrown from you. The person was standing here, thrown up and over the cliff. So in that respect, yeah, negative. The object was not in the motion before time equals 0, essentially. So we're going to discard that and just let time equals 6. How long would it take? Yeah, 6 seconds. After 6 seconds, it will fall. It will, and there you go. And that occurs at 6 seconds. Okay, well, that was all the questions. So I'm going to sign off now. So catch you later, and good luck with the SAT on Monday.